All right, so let's see this particular question now. Maximum sum subarray, right? So we are given an integer array a double r, this one, right? We need to find and return the maximum sum possible from all the subarrays, right, of this particular array, right? So what we mean by this is that we need to find such an array of such a subarray of this particular array which has maximum sum possible out of all the other subarrays of this particular array, right? And we don't need to return the actual subarray itself. We just need to return that maximum sum value, right? So this is the question pretty much. We need to find the maximum sum of a subarray of this particular array. And now maybe you can just pause this particular video and try to think of a solution. And once you are done, maybe you can just come back and see the solution here. So now to solve this particular question, how we can start, right? So essentially what we need to do is we need to find a maximum sum subarray, right? So generally when we need to find a subarray with a particular condition, what we can do is we can give the two-pointer approach or a sliding window technique that we have, maintaining a sliding window. Uh, we can just try to think if we can fit those techniques over here or not, right? Because subarrays are essentially windows, right? And we need to find the maximum sum subarray. That means, if we have a window, we can think of it like this. And then if we can just keep sliding that window one by one and keep checking, for the maximum sum. So that way, maybe we will be able to achieve, what we are trying to do over here, right? So in general, whenever you have a question, which asks you to find some kind of subarray or substring, right? You should give a shot to the two-pointer or the sliding window technique, right? I'm not saying that always a sliding window technique will work, in these situations where you are asked about a subarray or a substring. It might not be the best solution always. It might not be the solution at all in some scenarios. But then you should definitely think of it. If you're not able to think of anything else, anything better, this might really work, right? That's in general. But over here, how we can start is we can have two pointers over here, the start pointer and the end pointer, and both will be initialized to the 0th index to start with, right? And then what we will do is we will keep incrementing our end pointer by one every time, right? We will keep moving our end pointer to the right, right? And as we are moving to the right, we will keep adding the new elements to our sum variable, right? So we will have a sum variable which will track the current sum that we have encountered at this point in time for the current window, right? And we will just keep adding all the new elements that we are reaching to in this particular sum variable, right? That's what we will keep doing simply, right? Also, we will have another variable which will track the maximum sum at any point in time that we have seen so far, right? And what we will do is with every iteration, whenever we are reaching to a new element, we will add that particular element to our current sum, and then we will compare the current sum with the existing value of the maximum sum, right? And if my maximum sum value at any given point in time is less than my current sum, at that point, then I will reinitialize my maximum sum to my current sum, right? So that's simple. That's like a standard thing that we do, right? So I will keep doing that, and I will keep doing this till I hit a point where my current sum becomes negative, right? Because if now my current sum becomes negative, then now there is no point of moving forward with that particular sum, right? Because it is only going to reduce the sum of the next elements, right? No matter how big the sum is going to be uh, for the next elements, it is only going to take away something from that entire sum of the next elements, because this is a negative number now, right? So it is not going to add anything to my next sum, right? The next element sum. And what I'm interested in finding the maximum sum possible from a subarray, right? So definitely if I include this particular negative number sum in my upcoming sum, it is not going to give me the maximum sum. Definitely that particular sum, the upcoming sum, will be more uh, without this particular negative number, right? So that's why the moment I encounter a point where my current sum becomes negative, I will stop there and I will reset everything, right? I will start a new window. I will reset my starting and the end pointer from like the starting point of the current window to the next element, right? To the next element where I actually encountered a negative sum. I will reinitialize my start and end pointer to the next element, and I will reinitialize my sum to 0, right? Because now I'm starting a new window. So like now I will have to start afresh, right? So that's why I will reinitialize my sum also to 0, and then I will repeat essentially the same process here as well. I will keep moving my end pointer, and I will keep adding every element that I'm encountering in with to my sum variable, and I will keep comparing the sum with the maximum sum that I have so far. And I will just keep doing this till I again hit a point where my current sum becomes negative. If I hit a point like that, again I will reset my window and I will move my starting and the end pointer to the next element and make sum equal to 0. So that's what I will keep doing. And once I have done this for the entire array length, once I have iterated over the entire array, I will just return the maximum sum as the output of my function, right? Because that maximum sum will now contain the maximum sum that I have seen for any subarray in this particular array, right? So that's the entire solution of this particular problem. Now let's do one thing. Let's code this particular solution together. All right, so let's implement the solution that we just discussed. So what I'll do is I'll start by declaring a function over here. I can maybe call it as maximum subarray sum, right? And this will accept an integer array, right? Now over here, what I can do is I can start by taking the length of this particular input array, right? And then what I can do is I can initialize my start and the end pointer to 0, right? Then I can declare a variable to track my current sum. I can just name it as sum. And initially I will just put 0 inside of it, right? I will initialize it to 0. And then what I can do is I can declare another variable to track my maximum sum that I've seen so far at any given point in time, right? And what I will do is I will initialize it to a very, very small negative number. And why a very small negative number? Because see, I am not sure what is going to be my maximum sum, like how big or small my maximum sum is going to be, right? If my maximum sum happens to be very small, I still need to make sure that my current, like the initial uh, number that I actually assign to this maximum sum has to be definitely smaller than that particular maximum sum, no matter how small that maximum sum turns out to be, right? Only then I will be able to handle, you know, uh, actually capturing it, right? So that's why I will just initialize this to a very small negative number, which will be like infinity, negative infinity, right? And then what I can do is, and there can be multiple ways of handling this. This is just one way. I told you the what I'm trying to handle, but there can be multiple ways of handling this particular case, right? Now what I can do is I can run a while loop, and my termination condition would be while n is less than n. At every iteration, I will just keep incrementing my sum uh, with the current element, right? And I will also keep checking if I have to reinitialize my maximum sum, right? So what I'll do is I'll just check at any given point in time which one is greater, the current sum or the maximum sum. If current sum is greater, I will reinitialize my maximum sum to current sum, right? Now what I will do is I will check if my current sum has become negative at any point in time, right? So for that, I will have a condition over here. And if it has become negative, then I will have to reinitialize my sum variable to 0 because I'm starting a new window now. And also I will reinitialize my start pointer to the next number, right? Which is n plus 1, right? So the current element is at the end position, and I have to start my new window from the next element, so that will be n plus 1, right? So I will initialize my start pointer to n plus 1, right? That's what I will do. And then I will also increment my end pointer by 1, right? Because anyways, I have to move to the next element after, you know, treating the current element, right? So that I have to do regardless if I got the sum negative or positive, right? I will anyways move to the next element. But if I got the sum negative, then I will also move the starting pointer to the next element, right? So if this condition got true at any point in time, what will happen after that iteration, overall iteration, would be that both my starting and the end pointer would be sitting at the next number, and my sum will be reinitialized to 0, right? And I will be starting up fresh from there, right? So that's the entire idea behind this particular logic. And now at the end of the entire scan, once I am done scanning the entire array, I will come out of the while loop and I will return maximum sum, right? So this is what I'm trying to do over here. And this is the entire solution. Now maybe we can test this by running a particular test case, max sub array sum, I will call this. And I can give the input as the same test case that we saw while defining the problem. So it was 2, 3, minus 8, 7, minus 1, 2 and 3, right? This was the sample test case that we saw. Now maybe let's run this. The output should be 11, right? Let me run again. Okay, we need to import math because I made use of math over here to get the negative infinity. So I will just import math over here. And now if I run this, I get the output as 11, right? Which is right, because if you see this particular subarray, the sum of this particular subarray is 11, and this is the maximum sum. You can check it for yourself. This will be the maximum sum that you will get for out of any subarray of this particular array, right? So this is the solution entirely. And talking about the space and the time complexity, so we didn't use any extra space over here. So the space complexity will be order of 1. It will be constant. And the time complexity will be order of n, because we are just scanning the entire array once, right? So it will be order of n. There it will be linear time, right? So that's it for this particular video, and I will see you in the next one. Thank you.